Hey everyone, and welcome to The Explainer. I'm so thrilled you're here today because we're going to look at geometry in a completely different way. If you've ever thought of geometry as just a bunch of boring math rules you have to memorize, I want you to completely erase that thought. Instead, think of geometry as a series of highly satisfying visual puzzles just waiting to be solved. Once you know the secrets, every shape becomes a satisfying code you can crack.
Check out this incredible Da Vinci-style sketch on screen. Look at all those gears and levers. It brilliantly shows that triangles aren't just random lines on a page, they're perfectly balanced machines. They have strict, unbreakable mechanical rules. If you change one angle, the whole machine shifts to compensate. Today, we're going to learn exactly how to operate this machine.
Here is our roadmap for today's explainer. First, the 3 golden rules. Then we'll break down Rule 1, interior angles, Rule 2, exterior angles, and Rule 3, triangle inequality. After that, we've got practice putting it together, and we'll finish up with your turn, final challenge. All right, let's dive in.
Section 1. The 3 Golden Rules, Mastering the Basics.
Moving right along to Section 2, Rule 1, Interior Angles. Let's start with the absolute most foundational rule of triangle architecture.
So, the crucial point is this. The sum of the measures of the interior angles of any triangle is exactly 180 degrees. It totally doesn't matter if the triangle is tall, wide, squished, or perfectly even. If you add up the 3 inside angles, they will always hit exactly 180.
Let's see this in a classic algebraic setup. Imagine we have a triangle where the 3 angles are written as expressions, y plus 10, 2y plus 20, and 3y plus 30. Watch as we write this out step by step. How do we find y? Well, we use our golden rule. We take those 3 expressions, add them all up, and set them equal to 180. Next, we group our similar terms together. We have 1y, 2 more y's, and 3 more y's, so that gives us 6y. Then we add our plain numbers. 10 plus 20 plus 30 gives us 60. So we write down 6y plus 60 equals 180. Subtract 60 from both sides to get 6y equals 120, and finally, divide by 6. Bam! Y equals 20.
But hold on. Many students make a mistake in this step. They circle y equals 20 and just move on to the next question. Don't fall for that. The puzzle isn't finished. The question usually asks for the actual angles, so we have to plug that 20 back in. The first angle is 20 plus 10, which is 30 degrees. The second is 2 times 20 plus 20, which is 60 degrees. And the third is 3 times 20 plus 30, making 90 degrees. 30, 60, 90. Add them up, and what do you get? Yep, 180. Perfectly balanced.
Section 3. Rule 2. Exterior Angles. Let's build on what we just learned by shifting our focus to the outside of the shape.
If you take one side of a triangle and extend it out straight into a line, you create an exterior angle. Our second rule states that the measure of this exterior angle is perfectly equal to the sum of the 2 interior angles that are furthest away from it. You know, the non-adjacent ones.
Let's look at this diagram from our source material. We have triangle XYZ. Look down at vertex Z. The line extends out to form a large exterior angle of 135 degrees. Inside, way up at the opposite vertex X, is 65 degrees. We need to find the missing angle at Y. Setting up the math, our rule tells us that the 65-degree angle plus our unknown Y angle must equal the exterior 135 degrees. Now, let's see a quick trick. If you're given the exterior angle and one interior angle, you don't even need a complex equation. Just take that big exterior number and subtract the interior piece you know to find the missing piece. So 135 minus 65.
And there it is, 70 degrees. Doesn't it feel incredibly satisfying when that final piece clicks right into place? Section 4, Rule 3, Triangle Inequality. We've mastered the angles, so now let's transition to the sides with our final architectural secret. A quick test to see if a triangle can physically exist. For a triangle to close perfectly, the sum of the lengths of any 2 sides absolutely must be greater than the length of the third side. The fastest way to check this? Just grab the 2 shortest sides and add them together. Now be careful here. The sum must be strictly greater than the longest side, not just equal to it. If it's not strictly greater, the whole triangle will just collapse flat.
This brilliantly illustrates what happens when we test some numbers. Look at the first set, sides of 3, 5, and 10. The shortest are 3 and 5. Well, 3 plus 5 is 8. Is 8 greater than 10? No. Put a cross next to that one. The structure collapses. How about 6, 6, and 12? 6 plus 6 is 12. Is 12 strictly greater than 12? No way, it's equal. It still collapses flat. Finally, look at 8, 10, and 15. The shortest are 8 and 10. 8 plus 10 is 18. Is 18 greater than 15? Yes. Give that one a big check mark. The walls hold up, and we have a perfect physical triangle.
Section 5, Practice, putting it together.
All right, you have all the tools. Take a look at this homework problem. This is a common exam question, and teachers love it because it forces you to use multiple skills at exactly the same time. We have an exterior angle of 125 degrees at vertex C, and our two opposite interior angles at A and B are written as algebraic expressions, 2x minus 2 and 3x plus 7.
We know from Rule 2 that the two opposite interiors add up to the exterior. Watch the steps as we write them out. 2x minus 2 plus 3x plus 7 equals 125. Let's combine those x's first. 2x plus 3x is 5x. Then combine the plane numbers, a -2 and a +7 gives us a +5. So, writing that down, we have 5x plus 5 equals 125. We subtract 5 from both sides, leaving 5x equals 120. Divide by 5, and we get x equals 24. Beautiful, logical, step-by-step problem solving.
Section 6, your turn. Final challenge.
You have been doing fantastically. Now, I'm going to hand the reins of the explainer entirely over to you for our final knowledge check. I want you to grab a piece of notebook paper. I'm going to show you a puzzle, and I want you to try to find the hidden angle before I reveal the answer. Ready?
Here is your puzzle. We have triangle ABC. There's a straight line DE shooting off the top that is perfectly parallel to the bottom line BC. We're given two angles, 40 degrees up top and 37 degrees at the bottom left. Your mission is to find the measure of angle BAC, the angle right at the top inside the triangle. Go ahead and pause the explainer right now, sketch it out, and hit play when you have your answer.
Okay, let's write out the solution together. Did you spot the trick? Because the top and bottom lines are parallel, we can use alternate interior angles, that classic Z pattern. The 37 degrees at the bottom left zigzags straight up to the top, so we know one missing piece inside is 37. Same for the 40 degrees on the right, it zigs down to the bottom right angle. Now we know two angles inside the triangle are 37 and 40. By Rule 1, all three must equal 180. 37 plus 40 is 77. 180 minus 77 gives us exactly 103 degrees for angle BAC. Give yourself a massive pat on the back if you nailed that logic flow.
And that is how you conquer the triangle. Just 3 simple rules. Interior angles hitting 180, exterior angles summing their opposites, and the inequality theorem keeping the walls standing. These rules literally govern the architecture of the real world around us. So the next time you look at a bridge or a skyscraper, I want you to see the geometry puzzles holding it all together. What puzzle will you unlock next? Thanks for learning with me today, and I'll see you in the next explainer.